Okay then, so in this segment of the session, we're going to go over the Unity UI system. So we're going to use this to make stuff like health bars and score counters and that kind of thing. Obviously, in your games, having feedback to the player in the form of some kind of visual information on the screen is going to be very important. It would be kind of really bad if you had a game and there was a health system and you had no idea what your health is. So that's, of course, why we put user interfaces on our screens. But it's also useful for stuff like menus and that kind of thing. So I'm just going to kind of move some of the stuff out of the way from today's session earlier, and we're going to crack on with UIs. So the very first thing I'll do with UIs is I'm just going to add something on the screen. So if you go to Game Object to UI, there's a bunch of things we can add, and these are all very helpful kind of built-in components that Unity has. So this is going to be your very basic stuff, like a text, stuff like buttons, just images, anything like that. I'm just going to go ahead and I'm going to add a text first of all, and some weird stuff is going to happen. So first of all, it's added this gigantic box that's kind of off the center of the screen. So right down here in the bottom left corner is the camera viewport we had before, and in this gigantic box here is the canvas that you put UI elements on. When I added my text, Unity automatically added a few things here. It added a canvas and added an event system. The event system, we're not really going to need to go into and change anything on it for most cases, but the event system is the built-in automatic thing Unity has to read inputs and pass them to your UI system. So this is going to read things like, if I press up and down on the arrow keys, if I built a menu, then it's going to automatically select different items on the menu, stuff like that. So this is just for input. We don't need to worry about the event system. Just wanted to kind of let you know what that is. So don't delete it because the UI might not work depending on what you're doing. Just to make sure that's there. The other thing was the canvas. And as you can imagine, the canvas is where we're going to put our UI objects. A lot like an oil canvas if you're going to paint a painting. And this is kind of the bounds of the stuff we can add to the UI. So if I put something outside of here, it's not going to appear on the screen, obviously. And there's a bunch of different modes that the canvas can be in. So if we go to the canvas component, by default, the render mode is called screen space overlay. And what this does, everything that I put inside this rectangle, it's going to work out how to render that, and it's going to slap that over everything else that I rendered with my cameras. So after all the cameras have finished processing, all of the cubes and objects and player models and buildings and stuff in your game, it's then going to render this canvas and just stick it over everything on the screen. The other modes that we have on here, because that's overlay, the other modes we have are screen space camera, which is subtly different. That just renders this alongside everything else that a certain camera renders. So if I were to click this, I need to kind of attach a camera to it. So I'll take the main camera and drag it on there. This massive rectangle disappears, and if I hit F, which is frame select, it's just going to focus on just the canvas that I added. And now the canvas is exactly the same shape and size as my camera's viewport. That's if I have screen space camera activated. So what this is doing is it's just rendering every object in the canvas alongside everything else the camera's rendering normally. And we get different options here. So the plane distance is how far kind of from the camera's viewport all the objects in the UI are being rendered. Currently this is 100, and this means that everything on the canvas is being rendered 100 Unity units in front of the camera. If I move my text, I'll make this bigger. I'll get onto these settings in a moment, so don't worry about that. Just make it a bit bigger. If I put it behind something that's already in the game here, it's going to render that behind that object because the plane distance was 100. So we can get around that by going back to our canvas and changing the plane distance to something smaller. Something I think I mentioned to some people, but not everyone last time, is the way Unity works in 2D is it's basically 3D with hacks is the best way I can describe it. Unity started off as an entirely 3D engine, and they added the 2D functionality after the fact. So that's why if I go on my main camera, for example, I'll see that it actually has a Z position, which wouldn't make much sense if this were entirely 2D, because the Z-axis wouldn't exist. And you'll notice that the Z position of the main camera by default is -10, and this camera and everything else still exists in 3D space. What actually happens is all of the things I added, like the square earlier, is on a Z-axis of 0, but my main camera is a Z-axis of -10 because the camera is physically 10 units behind all of the 2D objects. If I were to make this 5, now it's in front of all my 2D objects, so they disappeared. I just mentioned this because, of course, with the canvas, it's important with this plane distance. I'm gonna want my camera behind all of these 2D objects, but I'm also gonna want my canvas to be between the camera and everything else. So if I make this -5, that's meant to have made it visible, but hasn't. Where has that gone? Where has it gone? What is there? Oh. Okay, I think something else might be happening there. I can get onto that later. I think it might be the... Okay, ignore some of what I just said there. I will look into that later. I think it's the sorting layers here, if I remember right. Yeah, okay, so we're actually going to make this screen space overlay and just work on that, because that's a lot easier to do. I'm going to go back on my canvas. If I press F, it takes what I'm trying to look at and it makes it kind of center screen. So I should have my text down here. So let's talk about how to put stuff on the canvas. If I select an object on the canvas, a lot of different kind of things appear on the screen. So if I click off it, then there's not much kind of anchors and stuff, but if I click on it, then I got these little kind of blue circles around the bounds of the text object. I have this little blue circle in the middle of it, and I also have this funky little looking thing in the middle. And you'll also notice the kind of outside of this got a slightly more solid white. And these are all important controls when it comes to positioning UI elements. And I'll try and go through each of them in turn and explain what they're doing. So the first thing is probably the anchor. So the anchor point is where the object's being drawn relative to. So if I move this carefully into the top left corner, you'll notice that the X position up here and the Y position up here are changing. That's because the text element is being drawn relative to this. So if I put this in the top left corner, now this object is being drawn relative to the top left corner, rather than in the center, which it was before. So Unity will snap this for me if I put it there, back into the center. I'm going to have it from the top left position for now, because we're going to place this text somewhere in the top left of the screen. This is most useful especially if you are placing UI elements programmatically. It's quite useful to just tell it, I want this in the top left, this anchor, and I can programmatically tell it what positions to take, and it will automatically put them in the top left corner. It just makes some of the maths a little bit easier. But it's also useful when we're designing in the Unity editor like this. These positions are going to be a lot more kind of natural, I guess. So that's the anchor point. You did also notice I can do this, but I'll get onto that in a second because that's a little bit more complicated. So, like I said, this is being drawn relative. And it's in fact this center point here, this little blue circle, where it's being drawn relative to. So this is kind of another sort of anchor point. This is called the pivot. So if I move the pivot, that's going to change the point which Unity kind of considers to be the kind of, well, the pivot of the object. So I can put this in the top left corner as well. And now, this object where it's being drawn, so this position 185 minus 181, is the distance between this top left anchor and this pivot point. So if I make this 0, 0, it's going to be exactly in the corner, but only if the pivot point and the anchor are in the top left corner. So this is why it's useful to kind of move these around, because now I can put in values like 10, 10, or maybe something a bit higher than that. If I say 50, 50, or sorry, minus 50, then that's just saying it's this text box is being drawn 50 away from the left-hand side of the screen and 50 away from the top part of the screen. These positions are, yeah, again, since it's relative, I want it to be 50 across and 50 down. I could also move this down here. If I wanted something in the bottom left corner, if I had my pivot on the bottom left and the anchor on the bottom left as well, then I could say 50, 50. And it's going to be 50 to the right and 50 up. I want to leave it in the top left for now, so I'm going to undo that. That's just simple moving objects around and kind of pivots and anchors. Any questions so far, or is that all kind of clear? Awesome. So once you've positioned stuff, then we have the width and the height of the object. So I can change these, of course. So I can have my width. I could make this something like 800. Probably important to note at this point that the 800 here means 800 pixels. So if I go back onto my canvas, in fact, it's probably important to talk about this now as well. On the canvas, it also added a canvas scalar component. And this is going to control the scales that are used on the canvas. By default, it's going to work on pixel sizes. So if I put it at a width of 800, it's going to be 800 pixels wide. But I can also change this to scale with the screen size. This is useful if you're designing a game that's going to be used on multiple different screen resolutions. So the original setting I had here, constant pixel size, if I tell it to be 800 pixels wide, it's going to be 800 pixels wide on every screen it's on. And if I put this on a 1080p screen, that might look great. If I put it on a 4K screen, this text is going to be tiny. So quite often, we want to scale this with the screen physical size, or the screen's resolution, rather. So if we say scale with screen size, this is going to scale it depending on some resolution value. We have a reference resolution that we set here. So the reference resolution is going to be kind of, I guess, a default value. If I make this 1920 by 1080, which is the resolution of a 1080p full HD screen, of course, if I tell this text to be 800 wide, that means this text is going to be 800 pixels wide on a 1080p screen. But if I were to double the resolution in both these axes on my actual screen, it's going to be 1600 pixels wide on that screen. So this is just the automatic scaling system that they use, and it's quite helpful. There's a couple of other settings on here, but they are not quite as... You kind of have to play around with these a little bit sometimes. But and we also have constant physical size. I don't use this very often, but this is a similar thing where you define things based on the physical size of the screen. So if I had a 1080p screen of this size, depending on these DPI values, it's going to draw a certain size. So 10 centimeters, for example. And if I had a screen that's double the size, even if it's the same resolution, it will still draw it the same... Would it be the same size? Would it be If it's a bigger screen, it would be a bigger physical size. But if I had a screen that's this big, 1080p, versus a screen this big at 4K, it will draw them the same size. I don't use constant physical size very often. I usually use scale with screen size, and that works for most cases for me. I appreciate this is a lot of kind of like background work to get kind of the stuff working, but I just mentioned all of this because it's quite helpful for kind of setup. So I'm going to go back to our text. So I'm gonna make this like 800 by maybe 250. Here's our text box. So we can just type in whatever text we want here, and in fact, I'm going to change the color first, so this is a lot more visible. So by default, every text box will just have new text written in it. We can write whatever we want here, like health, for example. And we might use this as a health counter, so we might have a number here. And we can change this through scripting later on if we want. And I will show you how to do that briefly. So like all text editors for most things, we also have options for the font size, the font style, that kind of thing, and the font itself. The way Unity handles fonts is you have to actually drag them into the assets folder and apply them by dragging them from the assets folder onto this font field here. I'm just going to skip that for now. It only has one font kind of built in, Arial, but I'll just mention that. That's how you use fonts. You have to actually drag them in because it's not sufficient to just have the fonts installed on your system because Unity is going to have to add them to the game when you build it. So you have to drag the actual font kind of original file into your assets folder, and then when you build the game, any custom fonts you've used, Unity is going to add them to the build of the game. It's got font size, so I can make that 40 or 50, and it's going to get bigger. Line spacing is just, how far away different lines or text are, but that's not as important. And then you've got your classic kind of alignment controls. You probably know how all those work. Options for whether it should wrap or overflow. So if I have wrap, then if I type more garbage into the field, it's going to just wrap to the next line. And if it was overflow, it would just continue going off the line, off the side of the bounds of the box. So that's kind of the basics of the text object. I don't want to spend too long just going over the basics of how this works because it's pretty obvious, I think. I hope. I'm going to go on to some of the other objects we can add to canvases now. Are there any questions at this point? Am I going too fast or too slow? Or hopefully that means just right then. I'm going to go to canvas. I'm going to right click on canvas and go to UI, and we're going to add. What's best to add? Let's add a slider. So let's get bigger. Bit like that. So I'm going to position this using these controls on the screen, similar to how I did for the text box. I'm going to anchor it to the top left. I'm going to put the pivot in the top left. I'm going to just move it down very slightly. Like most things, there's like convenience controls here. So if I've left clicked and like held left click to start dragging something, if I hold in shift, then it's going to look to a certain axis. So I can just move it down if I want. I'm going to put it about there. Let me get a little bit bigger. And Unity should help snap to other objects that are on the screen. So if it's going to snap to like this value here. It'll turn blue when it's snapping. So if I want to just position things so they're the same width or the same height, Unity helps me do that. So a slider is useful for if I want to send a value to a script, for example. So if this were on some kind of menu, this might be my volume slider. And in fact, if I play the game, I should be able to, just out of the box, kind of move this around. So this is just another convenient thing that Unity gives us by default. And there's different stuff you can do here. So you can change the different colors of it. So there's different color settings for if it's in a normal state, if it's highlighted, if it's pressed, selected, or disabled. You just change those colors. Stuff like a fade duration. So I think the fade duration is if you are holding it down and then you let go of it, it's going to fade between the different kinds of colors depending on the state of the slider. But the most kind of useful things about a slider are, I guess, passing these values somewhere in a script or passing values to it. So sliders let you define these minimum and maximum values. So if I made this 100, then it means that behind the scenes, the value on the left-hand side of the slider is 0, and the value on the right-hand side of the slider is 100. But this is kind of behind the scenes, and it's kind of hidden from view. This is just useful for scripting behind the scenes. We can also lock the slider to whole numbers. So if I lock that to whole numbers and make this between 0 and 10, for example, if I play the game again, this should lock my slider to those values. So I shouldn't be able to just drag it infinitely. It should just snap to between 0 and 10. And you might be able to see, although I made my screen mode tint red, I can kind of also change it here using the editor. That's all useful. Yeah, so that's sliders. It's actually behind the scenes, made of a bunch of the other kind of inbuilt components. So that was just to show you there are other kind of objects that you can add. The next thing I'm going to add is going to be a little bit more technical, but that's fine. So I'm going to add an empty game object. And I'm going to move this into the top left corner again, like I did for the other objects. Except this time, rather than adding any of the default Unity stuff to it, well, it is another default Unity thing, but it's not through this menu. So I am not going to right click and go to like UI and stuff here. I'm going to select the game object I just added. So I've anchored it to the top left. Its pivot's going to be up here. So these numbers look actually kind of weird because Unity does this sometimes, but they should look quite nice and round. It's 50 minus 50 now. I'm going to go add components, and I'm going to go, I can't remember what it is now. I think it might be layout. Yeah, it's layout. So moving things around like this is all nice and everything, but sometimes it gets a bit tedious. If I have a lot of elements, I just want Unity to figure out the position for me. There's ways I can do that. The first one I'm going to go on is called vertical layout group. And this and some of the other similar ones like it are some of the most useful things that you'll find with making UIs. A vertical layout group is going to take everything that's a child of it, and it's going to automatically lay them out vertically. I guess it's in the name. So I'm actually going to take the slider and the text, and I'm going to put them as children of this. And you might not have seen that, but the slider actually did move slightly, so if I undo that, you set the sliders here, and this text is here. I look very carefully. If I drag it underneath here, the slider moved up. And it did that because of the settings on the vertical layout group. So the vertical layout group takes whatever settings you had on these and kind of overwrites them and puts it where Unity thinks is best, depending on what settings we have on the vertical layout group. So just to go through the options here, we can change the spacing between objects. So I can change this to 50. And again, our slider will move that down. And that's because it's going to add a, if I select them kind of individually, you can see the bounding boxes of both. It's going to add a space of 50 between the bottom of this object and the top of the next one. And that's quite useful. We can also kind of do really fancy stuff here, like if I added a couple more text here, in fact, I had kind of different sizes to begin with, so I've manually given them different sizes. I can give them, or I can force them to have different properties based on this layout group. So if I say, that's probably not the right one, is it? I think I wanted the other one. I just undid that. I just remember which one it is. I think I need to make this one bigger, actually. If I... Oh, there we go. So... this is the child force expand option. If I make the layout group itself much bigger, then it's going to force these objects to kind of space themselves out within the layout group. If I untick height, then they're going to move back to their natural positions. And the same with width, although they're all the same width, so it doesn't matter that much. I always have to remind myself which way around these ones go, because these are a little bit more technical. New child scale, I think is... Oh, controls are... Okay, that is the one I wanted. So it's automatically laying out the objects using kind of like spacing them out. But currently, say the texts are all different sizes and the slider is a different size, and it's trying to kind of make them use the whole height of the vertical layout group. But I can control child size, and it's going to force them to take up a lot more. It's going to kind of like override the height of the objects. This isn't very useful for the slider, as you can see, because it's kind of stretched the slider out, and that's really awkward. But this is kind of useful to keep in mind if you have some kind of object that you want to lay out on the UI, and you want it to force it to have different sizes to take up the whole vertical size of the screen. So I'm going to just undo that again. There are there's a couple of other components like the vertical layout group. So if I remove that, and I can add a horizontal layout group, and that works the same, except it lays out things horizontally. For this, it doesn't make much sense because these are just naturally kind of vertical objects. Or we can add I think it's a grid layout group. So a grid layout group is similar, except it's now a 2D grid, so it's both horizontal and vertical. What it's done here is it's made every single object here a tiny little square. So this works a little bit differently. But you basically define a cell size, which is in pixels how big each cell should be. So if I made this like 300 by 300, this makes it a little bit clearer what it's doing. Each of the elements underneath it, every element that's a child of it, is now taking up 300 by 300 pixels, and it's laying them out in a grid. This is useful if you had something like loads of images that you wanted to arrange in a grid or something. Say if you had like an inventory system, you might use something like this to just display everything in the inventory in a grid pattern. And again, we can do spacing between these elements. So yeah, that's just some of the kind of some of the stuff that Unity builds in to kind of help you control where to put stuff on the UI. Any questions at this point? Oh.
Can you choose the one layout group?
Yes. So it's kind of a little bit complicated how it works. On any one game object, so on this one, I can only have one of those layout groups because of the way they work. If you had two, it would they'd kind of counteract each other because they're trying to achieve different goals that kind of don't mix, I guess. But you can, if I remember how to do this right, if I added a child game object of this one, say if on this parent that I have here, if I gave this a vertical layout group, so it's going to lay them out vertical like this, I'll add another couple of texts and make it a child of this object. So I have this vertical layout group on this game object. One of the children of that is itself a game object that if I add a horizontal group to that, now this is going to lay out things horizontally. So I can't have the horizontal and the vertical layout group on the same object, but I can have different ones on children of something that has one, if that makes sense. So everything in here is laid out vertically, but then this itself is taking up one of the vertical slots here that itself contains objects that are arranged horizontally. So you can imagine this as some kind of hierarchy, kind of makes it nice to lay out things. Any other questions at this point? No, if not, I'm going to kind of, what should we do next? Probably a health bar. So I'm going to do a little bit of scripting here, and I'm going to just show you how to make a real simple health bar. So I'm going to delete everything that we have in our canvas so far, and I'm going to add UI. I'm just going to add an image. This is going to be the simplest health bar you can imagine. Oh, actually, before we go into this, I should probably explain how this works. So this might look very confusing. So this is still the anchor point, but I can split the four kind of portions of the anchor. So I have to be very careful when I'm moving this. So if I get it in the center, then I'll move all 4 points together. But if I select one of these little triangle wedges, it's going to move them apart and I move them individually. And this is another way of laying things out. I can move the anchors kind of where I want. But if I, say, take up a quarter of the screen with the space between these anchors, it's going to tell this little image to kind of draw itself relative to all four of the anchor corners. And the way we do that is we define how much space there is to the left, the bottom, the top, and the right of the object. So if I gave these all a value of 50, oh, not what this said. So the left, top, the right, and the bottom. If I give these all a value of 50, this is going to tell it to draw itself with a space of 50 between itself on each of these edges, between it and the kind of bounding box, the four anchors. And this is useful if you want objects to just take up a portion of the screen. You don't want to tell it exactly how many pixels to take up. You just want to tell it, I want you to take up this much of the screen with this much padding around it. That might be useful if you have like a menu and you want it to have a kind of a background image and that kind of thing. I just thought I'd mention that because I glossed over that earlier and didn't come back to it. Yeah, when it comes to these anchors, kind of playing around with them, putting them in different positions and different orientations is going to be useful for helping you actually lay out your UI. There's a lot of different things you can do with it. So I'm going to just undo that. I'm going to put our anchor again in the top left. I'll put my pivot point there again, and I'm going to give it a position of 50 and minus 50. These seem to be my favorite numbers currently, I guess. And I'm going to make this a little bit wider, so however wide we want it. Right, so I think, just give me a second, I'm just going to look some of the things up. I want to check if this is the right one. Yeah, I think that's right. Okay, cool. I think it's fine. Cool. Hang on, do I want this to be an image? I think so. Yeah. Yeah, okay, so we're going to use this as the health bar. So actually what I'm going to do, make this a little bit bigger, we'll make it look nice. So I'm going to add another image, and I'm going to make it a child of this one. I just make it a little bit smaller. And turn this green. I think that's hopefully clear enough to see. I'll make this one like black, so it just has a high contrast. Cool. So as you can imagine, for a health bar, we're just going to want to take the kind of the width of this green bar and tell it to change over time. So, well, not over time, when I get hit by something, if I lose health. So I'm going to create a script by going right-click, create C# script, and I'm going to call this health bar. So health with a capital H, B, capital B. And open that script up. And here we are with our health bar script. So the first thing I want is some kind of public variable so I can attach the health bar image to it. So if I say public, and the class is called image, but we're going to run into a problem here. So I'm going to tag image, but Unity is not going to know what this is. But I'll fix that in a second. So I'm going to call it, public image health bar, and I'm going to call it health bar. And this is something we're going to drag in the Unity editor. But you'll notice that if you have image here, it just has a red squiggly line underneath it. And that's because Unity doesn't know what this is yet. That's because the UI components are in a different namespace. So a namespace, the terminology is a little bit annoying here, but a namespace is basically kind of a collection of classes, functions, that kind of thing. And we use namespaces because sometimes we might have classes that are called the same thing, but have very different uses. So if we had, I'll give an example here. Say if we had some kind of library for drawing shapes, and we had some class called box, and we had some other collection of objects that you might add to a game, like crates and stuff, and one of those also has a class called box. If we just had those in the global namespace, then Unity's not going to know which box we mean when we type in box. So it has this system of separating them out and kind of packaging them together. We've actually been using namespaces this whole time because we have this using Unity engine. Unity engine is a namespace, and it contains lots of the helpful stuff that is unique to Unity. So when we were using, back in the last session, when we were using stuff like rigid body 2D, that's contained in the Unity engine namespace. The UI stuff is contained in a separate namespace, and it's actually, we put using Unity engine.ui, and now the squiggly line disappears. So all of the stuff for UIs is in this namespace. Image is, the text component is, the slider component is, all of those things are in this namespace. Now we've imported it, or now we're using it, we can access everything that's in it. If you ever do use two namespaces that have the same name, you can differentiate between them. So say if Unity Engine and Unity Engine.ui both, for some reason, have a class called image, you can tell them apart by saying, over to the top there, you could say that. So you can just put the namespace name down before it, and it will be able to tell the difference between the two. This is going to turn out great because Visual Studio is going to tell me I can simplify the name just by getting rid of that because it knows where that is, because there's not a conflict. So that was a little bit of a long-winded explanation. Apologies about that. Now we want to make the health bar a certain size based on the health. So I'm going to do this in the update function, and to remind you, the update function is run every single frame. So while the game's running, it's going to run update every single time the screen is redrawn. I'm going to say, need to remember how to do this. This might take me a while. So I want it to be, I think I want to say the transform. I basically want to, if I go back on this, I want to get this image, and I want it to find the width, and I want to make this width change. So actually the first thing I'll do is give myself another variable here. I'm going to call it private, because I don't want this to be accessible to other scripts. I'm going to call this float health. Oh no, float. I'm going to call it bar size. That's going to be the width that it starts out as. I'm going to assume this doesn't change over time, the width. So I'm assuming that this UI isn't scalable in any way. So that's just the default size. And I'm actually going to add start back here. So void start. I press enter there. It should kind of fill that out for me. It fills out with private, but that's not important. I'm going to say bar size equals health bar dot, and it's actually called a rect transform. I'll get onto that in a second. Dot, I need to remember which one this is because it's a little bit complicated. I think it might be I think it's anchored position dot. That's the position. This might be. Bear with me for a second. I need to remember which one this is. Sometimes when it comes to these kind of things, I need to look them up to remind myself of exactly what I need to use. I think it might be. Is it? It actually might be .rect. Yeah, we go. Okay, so it's health bar .rect transform .rect .width. And to go over what all of that means, I'm going to come back into Unity. So normal objects have a transform component attached. UI elements have a special kind of transform called rect transform. And it acts mostly in the same way, except when we have the anchors involved, it just gives us more things to do with it. So it's a special kind of transform. And the thing we want to access is the width. So when I said healthbar.rect transform, I got this component. And then when I said .rect, this is actually getting me, I believe it's these 4 values, or like this kind of segment of the values here. So the rect is just it's controlling where this is drawn. And then when I said .width, it was getting this in particular. And that's all good. That's what we want. Now we know what the width is when it starts out. We want to modify the width depending on some health value. So I'm also going to say, just as kind of some kind of random values to throw out there, I might say private float. Actually, let's call this max health. And I say the max health is 100. And then I'm going to say, and I'm going to make this one public just because I want to be able to modify this on the Unity in the editor, but you might make this private in a real script. I'm going to say public float health. And this is going to be also 100 by default, but we can change this. Now we're going to say health bar dot rect transform dot rect dot width equals, and I think this might actually complain. Okay, cool. I will fix that in a second. Actually, let me. I think I can do. Hang on. It's not available. We don't need. Give me a second. I think it might be a. Oh god, which one is it? I can't remember. It's not rect. I think you might be able to do. I think we can set the scale actually. It's probably the easiest way to do this. I'll change the scale here, so it's like 0.5. What does that do? That's actually a way easier way to do this. Okay, yeah, we're just gonna do rect transform.local scale. Yeah, we actually don't need to do this. I think I was doing that slightly wrong. So I'm actually going to say healthbar.rect transform.local scale equals. I'm going to say new vector. I think it's a vector 3 or is it a vector 2? Yeah, it's a vector 3. Okay. So the local scale is just going to be the scale of that transform. Unlike the transform position and the transform rotation, which you have transform dot position and you also have transform dot local position, because the position, if you set it dot position, then it's going to set the world position. If you set dot local position, it will set the position of an object relative to its parent. there is only a local scale. There's no like transform.scale, and that's because scale is always relative to its parent. It's never like a global scale because that doesn't really make sense. So we'll say the local scale. And we want the x to dependent on its health value. So we're actually going to say the x is like health divided by max health. The y is going to be 1 and the z is going to be 1. So we don't want the y and the z scales to change if the health changes. If we kind of have that as that is, anyone need any more time to copy that out, or we're good? If we go back into Unity, since we're going to play now, but something. No, okay, cool. If we take the health bar script and we put it on the image, the green one, we're going to need to drag the health bar. So I'm actually going to need to drag that image onto the health bar variable. That's all good. Now, if we go into the game mode, if we play the game, that's going to happen again because that was the last session. If I change the health on the fly, so if I change this value to something like 40, our health bar is going to change shape or size to account for that. So in a real game, you'd have some kind of system where an enemy would hit the opponent, the player, and you'd have some code that changes this value behind the scenes for you, but this is just kind of debug. I can change the value directly, so I can set this to any value I want, and it's going to automatically make the health bar the right size. The only thing here is if I make this bigger than 100%, it's going to exceed the size of what it was to begin with, because now its scale is bigger than 1. But we can write some other code to account for that. So remember that when you go out play mode, everything returns to normal. None of the changes I made were destructive. So I can actually just say, I could do this in a variable. So rather than just manually, rather than calculating it down here, I could say float size equals health over max health. And then we can say, basically, if the size is above 1 or below 0, bound it to between 0 and 1. And there's actually a really easy way to do that. I'm going to say size equals, and there's a whole class in Unity for common math functions, and it's called mathf, which is kind of annoying. It's a weird name. Rather than math, it's mathf. I don't know why that is. And I'm going to say mathf dot, and it is clamp. So I can clamp this value, so the value size, to between some values. So I can give it a min and a max, and it's going to make sure that this value never goes below the min and never exceeds the max. So I will say 0 and 1. But that said, there is actually another thing in the maths class that does that for us. I could also have said size equals mathf.clamp 01 size, because clamping values between 0 and 1 is such a common thing that you do that they've just made another version of that function for us that just clamps it between 0 and 1. So then I'm going to say, instead of putting that down there, I'll say size. So I'm going to calculate the size based on the health and the max health. I'm going to clamp it between 0 and 1. I can get rid of one of those by adding a comment. So a comment, if you put 2 forward slashes before a line, it comments it out. That's useful if you want to add notes about your code, or if you just want to remove parts of it while you're working on it. So this line isn't going to be calculated. So yeah, I'm going to say the size is between 0 and 1. So then I'm going to set I'm going to set the scale to that size in the x-axis and then 1 on the y and z. So I'll go back in here, play the game again. And if I change this to 120, or even like 5,000, it should just not exceed the bounds. Or it shouldn't go over 1. And if I set this to minus 100, it doesn't go below 0. Right, that's a very basic health bar. Are there any questions about the health bar? Fantastic. So there's about 10 minutes left in this segment, so I can very quickly also show you how to add just a score counter. That's going to be a very similar process. So I'm going to add a text object. I'm just going to leave it the default name. I'll go back into the scene view. I'm going to move its anchor into the top. Not make it a child of that image, because that's going to be a bit confusing. I'll put the anchor in the top left. I'm going to put it below here. Just going to make it bigger. About that size. Going to make the text a lot bigger, so like 50. I'm going to make the color white, just so I can see what it is. See what the text is saying. And I'm going to just, by default, the text in this is going to be score. So if I want the score to update based on some value in the game, we can do that with scripts as well. So I'll just do that for a little second. Just give you a little bit of time to see what the settings are. Cool. So I'm going to. Okay, shall I move on now, or have you all covered that? Cool. Okay, I'm going to make a new script. I'm going to right-click, say Create C# script, and I'm going to call this score counter. And then I'm going to open that up. So again, it's the Unity template, an empty new component script that I guess is by default. First step is we're using UI components, so I'm going to have to say using Unity engine.ui. Now I'm going to be able to use UI components. I'm going to be editing a text component, so I'm going to have a public variable here called public text, and I'm going to call this score text. That's something that we'll add in the Unity editor. I'm going to get rid of the start function here because I don't think we need it. And then I'm going to have just a variable here for us to test with. Public, I'm going to make it an int, so an integer. So whole number, public int, score. And that's something we're going to make 0 by default. And we're just going to change this in the editor like we just did for the health value. So updating the score text on the fly is actually dead easy. All we say is score text, which gets us the component. And then we say dot text, which gets us the actual text field on that component. And then we can say equals and tell it what text it should say. So by default, we had it saying score. So I'm going to use the double quotes, and I'm going to type score in there. So score, and then a colon, and then a space. So that's going to say what it currently already says. And then I'm actually just going to say plus score. Apparently I can't spell score. And this is quite nice. Unity or C# by default, if it sees that this is a text string and this is an integer, it's going to automatically convert whatever this number is to a string as well, and it's just going to concatenate those two strings together. So this is going to say score, colon, then a space, then whatever our score is. So let's go ahead and add that to our text in Unity. I'll go back to the text. I'm going to take our score counter script. I'm going to drag it onto the object. And now I need access to the text component. So I'm going to actually drag the text component. If I just move that out of the way, I'm going to take the text component on this same object and drag it down into this field. And now I should be good to go. So I'm going to play the game again. And it just says score 0. So whereas before it just said score, it says score 0 because my variable is 0. So that looks like it's working good so far. If I go to the script and just change the value to whatever I want, so 10, it's going to update the UI to say 10. And of course, if this was a real game behind the scenes, I have some way of calculating a score for me rather than typing it in here, but this is just an example. So this might be something like, if my game has a number of collectibles, every time I collect a collectible, it will update some value behind the scenes and then take that value and send it to this text script component. This text script, yeah, there you go. And it's going to update what's on the UI. Are there any questions about that part of the tutorial? Or are we all good? Fantastic. I think I will wrap up the UI tutorial there. If you have any general questions about Unity or anything we've done today, then feel free to ask. If you think of a question later on today, ask on Discord, and I'll be very happy to answer your questions. But for now, I think that's it. So thank you for coming and listening. I hope that was helpful. There we go. Stop recording.